Okay, we're going to go over the review for Test 2, Chapters 4 and 6. Question 1. Is wine good for your heart? Is there a relationship between wine consumption and the heart disease death rate? The table below gives data on average per capita wine consumption and heart disease death rate in 19 countries. So we have this data. Before I go to my calculator, I need to decide a few things. I need to figure out my input, and I need to figure out my output. So in this example, the input will be wine consumption. That is my X, my explanatory. How much wine you drink explains the heart disease death rate, which is my response, my output, my Y. Heart disease death rate. Okay? So that's step one. We're going to make sure what's our input and what's our output. Then we can go ahead and start sketching this out. On my x-axis, I'm going to have my wine consumption. On my y-axis, I'm going to have my heart disease death rate. And I have to determine what I want to start with and what I want to end with. So I look at my data for wine consumption. If I look at my data, it looks like the lowest number is 0.8 and the highest number is 9.1. So I'm going to start with 0 and go to 10, counting by ones. So I'll do 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. For my y-axis, it looks like the lowest is about 71 and the highest is 300. So I'll start at 50 and I'll count by 50s to 350. So we have 100, 150, 200, 250, 300, 350. And notice I still haven't done my calculator, anything with my calculator, but I have my X, I have my Y, and I have my scale. Now we're ready for our calculator. So the very first thing I do in my calculator is I go to Y equals. I go to Y equals and I make sure that none of the plots are highlighted, and I make sure that there's nothing in Y equals. That's step one. Then I want to put the data in my calculator. So I push stat, number 1 for edit, and I put all of my wine consumption in list 1, and I'm going to put all of my heart disease death rate in list 2, double, triple checking that all the numbers are correct. Then I'm going to do the second step. Once the data is in the calculator, I'm going to tell the calculator I want a scatter plot. So I press second, Y equals. I push number 1 for plot 1. I push enter on top of on. I choose the scatter plot by pushing enter on top of the scatter plot. In this case, my X is list 1, so I hit second 1. My Y is list 2, so I hit second 2. And for the mark, I'll use the box. So my second step is setting up the plot. The third step is to set up the window. So I press the window button and I refer back to my table, my chart. My X starts with 0, goes to 10, count by ones. So my X minimum is 0, X maximum 10, scale ones. My y-axis starts with 50, goes to 350, counting by 50s. So my y minimum is 50, y maximum 350, and I count by 50s. Then when I push graph, we see our scatter plot. And I'm going to sketch that on my paper. Okay, that is for question 1. Now we're going to go ahead and answer the rest of the questions. Question 2. What is the form or shape of the scatter plot? And the answer is linear. The dots form a line. What is the correlation? Well, to find correlation, we go to the calculator, we push stat to the right for calculate, choose number 4 for linear regression. Now, if your calculator looks like this one, X is list 1, Y is list 2, then go down and calculate. If your calculator just says linear regression, linreg, then you're going to put list 1, comma, list 2, and push enter. But we all get the same results at the end. And of all these numbers, R is our correlation. So in this case, correlation R is negative 0.84. Then the next question says, explain what the correlation means as far as strength, association, and in the context of the problem. So our correlation is negative 0.84. Strength would be strong. Why? It's close to negative 1. When you're close to negative 1 or positive 1, it is strong. The association is negative, and in the context of this problem, as wine consumption increases, the heart disease death rate decreases. So in the context of this problem, as wine consumption increases, the heart disease death rate decreases. Okay, which leads us to the next question. Based on the value of the correlation, does that mean wine consumption causes the disease death rate, the heart disease death rate? Well, let me highlight a few words. Correlation causes. Once we see that, the answer is no. Correlation doesn't imply causation. Correlation doesn't imply causation. Then it says, explain what the coefficient of determination means in the context of the problem. So in this case, our coefficient of determination is r squared. And you notice that r squared is 0.71. So r squared is 0.71. And what does that mean? 71% of the data is explained by the line. 71% of the data is explained by the line. The next question says, calculate the linear regression. Well, going back to our calculator, we did linear regression earlier, and we have y equals ax plus b. We need to put the a in for a and the b in for b. We're going to round appropriately to 3 decimal places. So our linear regression would be y equals negative 22.97x. Don't forget to put the x. Plus 260.56. So the linear regression is y equals negative 22.97x plus 260.56. Question 3b, sketch the graph on your scatter plot. So, I go over to my calculator, I press y equals, and I enter my linear regression. We do negative, and make sure you push the negative button. Negative 22.97, x is located right here, x plus 260.56, enter, then press graph, and you should get the line that goes right through the data. So I go to my chart, my graph, my scatter plot, and I draw my line. Okay. Next, explain the slope in the linear regression in the context of the problem. So, slope is our number in front of x, so our slope will be negative 22.97 over 1. Now remember, how do we explain slope? Slope is output over input. And in this example, our output is heart disease death rate, our input is wine consumption. So, negative 22.97 would be our heart disease death rate, and the 1 would be our wine consumption. It's always output over input, output over input. So in this case, every 1 liter of wine consumed the heart disease death rate decreases 22.97. Every 1 liter of wine consumed, the heart disease death rate decreases 22.97. That's the explanation of slope. Next question. Explain what the y-intercept of linear regression means in the context of the problem. The number in front of x is our slope, the number at the end is our y-intercept. So in this case, our y-intercept is 260.56. Now how do we explain a y-intercept? A y-intercept is when x is 0. So in this case, x is wine consumption. So if 0 liters of wine are consumed, the heart disease death rate is 260.56. If 0 liters of wine are consumed, the heart disease death rate is 260.56. Now sometimes the y-intercept may not make as much sense, but the way we explain it is always the same. It's when x is 0. Okay? Now, next question. Use the line of regression to predict the heart disease death rate for a country that has a wine consumption of. So, our linear regression again is y equals negative 22.97x plus 260.56. So for 1 liter, since x is wine consumption, I'm going to put 1 in for x. So y equals negative 22.97 times 1 plus 260.56. So I can go to my calculator. I can do negative 22.97 times 1 plus 260.56. That gives me 237.59. So the sentence would be, every 1 liter of wine, oh sorry, not every, sorry, at 1 liter of wine consumed, the heart disease death rate is 237.59. At 1 liter of wine consumed, the heart disease death rate is 237.59. Now the next three are the same, but we change how many liters of wine. So I'm going to go ahead and show the work, but I'm not going to go ahead and write the sentences because the sentences would be the same. The only difference is we're talking about 5 liters. So if I did 5 liters, typed it in our calculator, we would get 145.71. So at 5 liters of wine consumed, the heart disease death rate would be 145.71. For 9 liters, negative 22.97 times 9 plus 260.56. You get 53.83. So at 9 liters of wine consumed, the heart disease death rate would be 53.83. For 15, negative 22.97 times 15 plus 260.56. 15 gives you negative 83.99. So the sentence would be, at 15 liters of wine consumed, the heart disease death rate would be negative 83.99. Well, that's interesting. And that kind of leads us to our next question. Explain why you got the answer you did for 15 liters. You can't have negative 83.99 deaths. So that is called extrapolation. And it's not really because it's negative. That is just a good sign that there's an issue going on. But extrapolation means we're predicting beyond the data. And when you predict beyond the data, the results are more likely to be unreliable. Excuse me. Okay, next question. For 4b, we're not given liters, but we're given the heart disease death rate. So again, our equation is y equals negative 22.97x plus 260.56. Remember, x is number of liters of wine consumed. Y is the heart disease death rate. So we would plug 200 in for y this time, not in for x. And we would use algebra to solve that. So we have 200 equals negative 22.97x plus 260.56. So to solve for x, we would subtract 260.56 from both sides. Which gives us negative 60.56 equals negative 22.97x. Then I would divide by negative 22.97, divide by negative 22.97, and we would get x equals 2.64. Now, if I was going to write that in a sentence, for a heart disease death rate of 200, the number of liters consumed would be 2.64. Remember, x is our liters of wine consumed. So if I was going to write this in a complete sentence, the heart disease death rate would be 200 when the liters of wine consumed would be 2.64. Okay. Second question is, what happens if you have 100 as the heart disease death rate? Again, 100 would go in for y. And we would solve for x. 100 would go in for y, and we'd solve for x. Again, we would subtract 260.56 from both sides. which would leave us with negative 160.56 equals negative 22.97x. Then to get rid of times negative 22.97, we would divide by negative 22.97, which would give us the answer of 6.99. Now remember, x equals 6.99 is the liters of wine consumed. So, at a heart disease death rate of 100, the number of liters of wine consumed would be 6.99. At 100, as the heart disease death rate, the liters of wine consumed would be 6.99. Okay? Which leads us to question number 5. Question number 5 is a different scenario. Question number 5 reads, researchers studying acid rain measures the acidity of precipitation in the Colorado wilderness area for 150 consecutive weeks. Acidity is measured by pH. Lower pH values show higher acidity. The acid rain researchers observed a linear pattern over time. They reported the least squares regression to be pH equals 5.43 minus 0.0053 times weeks. So this seems like we're starting off very difficult, but actually a lot of the work has already been done for us. Normally we're given the data and you have to find the linear regression. We're given the linear regression to start with, but the problem is we need to graph it. So again, step 1, input, which is our explanatory, would be our weeks. We need to identify that first. And our output, which is our y, our response, would be our pH. So weeks is our x, pH is our y. Weeks is our x, pH is our y. You tell me how many weeks. That will explain the response of the pH. Weeks is the explanatory, pH is a response. So, when I go to graph, on my x-axis will be weeks. On my y-axis will be pH. Now, we need to determine a scale, but the issue is we're not given the data. So hopefully we can figure out what the scale would be within the problem. Well, for weeks, they tell us it's a 150-week study. So we would start at 0, maybe count by 25s, all the way to 150. So since it is a 150-week study, we start at 0, we go to 150, and we count by 50s. Now the pH is a little trickier to find. To find pH, we look at the equation. And if you notice, it appears to start at 5.43 and go downward, negative. So if it starts at 5.43 and go downward, I'm going to assume if I go up to 6, I'll be okay, and go down to 0 should cover everything. Now this is an assumption, but it should work out. So knowing that it begins at 5.43 and goes downward gives me my pH scale of 0 to 6. Now I need to graph it. Well, I'm going to go to my calculator, but remember, we just did a whole problem with wine consumption. So let's clear everything. We go to y equals, I clear the old equation, and I turn off the plot by going up to it, plot 1, and pressing enter. Once everything is cleared, in y1 I put our equation. Our equation is 5.43 minus 0.0053, and we'll use x for pH. So we type in our equation into y equals 5.43, make sure you use the subtraction symbol, 0.0053x. So in y1 we put 5.43, subtraction, 0.0053x. Once we have the equation of y1, we press window. We notice that our x goes from 0 to 150, counting by 25s. So x minimum 0, x maximum 150, scale of 25. Our y-axis 0 to 6, counting by 1s. Y minimum 0, y maximum 6, y scale 0. Then I press graph, and we see our line. Notice it starts at about 5.43 and goes downward. So about 5.43 and goes downward. So we should have that on our paper, which matches what we have in our graphs. Okay? Once we look at it, we're going to go to our next question. Is the association positive or negative? Well, we look at our graph and we notice that it's going downward. We notice that our graph is going downward. And if our graph is going downward, that is a negative relationship. The other thing we can look at is the slope. Our slope is negative, which would make the line go downward as well. So, for this question, is the association positive or negative, we put negative. And what does association mean? In this problem, as weeks increase, the pH decreases. As weeks increase, the pH decreases. Then it asks for the slope. Now remember, slope is the number in front of the x. And in this case, weeks is our x. So our slope, which is in front of it, would be negative 0.0053. Don't forget the negative. And we're going to call that over 1. My next question is, explain the slope. Remember, slope is always output over input. Slope is always output over input. So in this case, output is pH, input is weeks. So our explanation would be every 1 week the pH decreases 0.0053. Every 1 week the pH decreases 0.0053. Remember, slope is always output over input. Output over input. And our very first step was determining which is output and input. Explanatory response x, y. Next question. What is the y-intercept? Well, the number in front of x is our slope. The number at the end is our y-intercept. So in this case, our y-intercept is 5.43. And how do we explain a y-intercept? A y-intercept is always when x is 0. When x is 0. So in this case, x is weeks. X is weeks. So at week 0, the pH is 5.43. At week 0, the pH is 5.43. Now, like the last problem, it says, according to the regression line, what is the pH when I give you weeks, and what is the weeks when I give you pH? So notice 1 week. Remember, weeks are x. So I use my equation, pH equals 5.43 minus 0.0053 at week 1. So 5.43 minus 0.0053 times 1 gives you 5.4247. And if I was going to write down a complete sentence, I would write, at week 1, the pH is 5.4247. At week 1, the pH is 5.4247. At 150 weeks, again, weeks is X. So we plug in 150 in for X. And we get 4.635. So the sentence would be, at week 150, the pH would be 4.635. At week 150, the pH is 4.635. Now, for those two examples, we're given X and asked to find Y. Given week and asked to find pH. In the next two example, we're given pH and asked to find week. So the 5 would go in for pH. 5 equals 5.43 minus 0.0053 X. Then we'd have to solve for X. So we would subtract 5.43 from both sides, which gives us negative 0.53 equals negative 0.0053x. Then I would divide by negative 0.0053x, just negative 0.0053, divide by negative 0.0053, which would give us x equals (81.13). If I was going to write that as a sentence, the pH will be 5 at week 81.13. The pH will be 5 at week 81.13. Now the next question has 4.75, so I'm going to do that on the side here. But again, pH goes in for the Y, the pH. So it's 4.75 equals 5.43 minus 0.0053x. 4.75 equals 5.43 equals 0.0053 x. To solve for x, we would subtract 5.43 to both sides. Which will give us negative 0.68 equals negative 0.0053x. To get rid of times negative 0.0053, we divide by negative 0.0053, which gives us x equals (128.3). So in a sentence, the pH will be 4.75 at week 128.3. The pH will be 4.75 at week 128.3. Okay. Moving on to question 6. Question 6 talks about experiments. Question 6 talks about experiments. First example. Is it true? Does listening to classical music during a test help improve test scores? A researcher would like to test if listening to classical music during a test improves test scores. First, they ask you for a flowchart. You may notice that they do not ask for a table. The reason why they don't ask for a table is there's only one thing that we're testing. We're testing classical music. Well, the flowchart, it always starts with randomly assign. A flowchart always starts with randomly assign. In this case, we're testing classical music. Now, in order to be an experiment, you have to have a control group. So if one group, the treatment group, gets classical music, the other group will get no music. The other group will get no music. So we're going to have two groups, classical music, and no classical music. And at the end of every flowchart, we have compare results. So remember, a flowchart always begins with randomly assign. It always ends with compare results. In this case, there's only one thing that we're testing, classical music. And we have to have a control group, which is no classical music. Then we'll answer the questions. Our factor, in this case, what we're testing, is classical music. There's only one thing that we're testing, so therefore we only have one factor. Then it asks for treatments. A good way to understand treatments is to skip down to how many groups you need. Well, we need 2 groups, therefore there must be 2 treatments. Treatment number 1, classical music. One group will get classical music. That's the treatment. Treatment number 2, no classical music. Again, since we have 2 groups, we have 2 treatments. Classical music, no classical music. And then the response variable is what we're going to measure at the end. In this case, it's to try to see if we can help improve test scores. So, our response variable is the test score. That's what we're going to measure at the end. And it says control if there is one. Well, if it's an experiment, there needs to be one. And the control group in this case is no classical music. Next question. What characteristics should you be looking for when you select subjects to participate in this experiment? Well, we're testing to see if classical music help improves test scores, so this should be done on people who take tests, such as students. Since we are trying to improve test scores, we need people who take tests, such as students. What are some lurking variables or concerns with this study? Well, the type of classical music, maybe the volume of the music, if they studied, how they studied, and again, you can list anything that's related that could have an effect on this study. Okay. Next question. Mr. Grocher would like to improve the test scores of his statistics students. He would like to know if study notes or my math over a combination will improve the test scores of his students. Notice here we're dealing with study notes and my math lab in a possible combination. So since we have 2 factors, study notes and my math lab, and we're mixing them, now we introduce the table. So on one side I'm going to put study notes, and then the other I'm going to put my math lab. Now notice they did not give us levels. They didn't say 2 sets of study notes, 1 set of study notes, 0 set of study notes. They didn't say 5 hours of my math lab, 1 hour of my math lab. So if the levels are not given, the assumption is yes, you get it, no, you don't. For my math lab, yes, you get it, no, you don't. And the levels basically start forming the rows and columns of your table. So study notes, yes, no. My math lab, yes, no. So this group will get yes, my math lab, yes, study notes. So I'm going to put M for my math lab, S for study notes. This group's going to get yes, study notes, but no, my math lab. So I'm going to put an S for study notes. This group's going to get yes, my math lab, no study notes. I'm going to put an M. And this group will get no, my math lab, and no study notes. And the whole point of the table is to notice that we need 4 groups, 4 treatments. So we go to our flowchart. Our flowchart starts with randomly assign. We need 4 groups. We're going to have the My Math Lab and Study Notes, Just My Math Lab, Just Study Notes, and the No My Math Lab, No Study Notes group. And at the end of every flowchart, we compare results. Remember again, every flowchart starts with randomly assign and ends with compare results. In this case, we have 4 groups. Under factors, we have My Math Lab and Study Notes. There are 2 factors, but there are 4 treatments. My Math Lab and Study Notes together, Just My Math Lab, Just Study Notes, and No My Math Lab, No Study Notes. 4 treatments. 4 treatments. The response variable again is test scores. There are 4 groups that are needed. The control group is the one that gets No My Math Lab, No Study Notes. That is the control group. And lurking variables, again, could be if they actually purchased My Math Lab, if they used My Math Lab, if they purchased the study notes, if they're using the study notes. Under lurking variables, you can put things that are related that could affect the study. That is experiment 2. Experiment 3. Does drinking 2 1 or 0 of energy drinks and or 2 or 0 cups of coffee help people stay awake? Well, in this case, we again have 2 factors. We have energy drinks and we have coffee. And this time they give us the levels. Energy drink is 2 1 0. Coffee is 2 0. And again, the levels determine the rows and columns and help us figure out how many groups we need. So this group is going to get 2 energy drinks, 2 coffee. This group will get 2 energy drink, 0 coffee. And again, notice I'm at least putting E and C for energy drink and coffee. Don't just put the numbers, then I won't know which is which. 1 energy drink, 2 coffees. 1 energy drink, 0 coffee. 0 energy drink, 2 coffees. 0 energy drink, 2 coffees. 0 coffees. And that gives us our groups. And if we count them up, 1, 2, 3, 4, 5, 6 groups. 6 groups. So this is 2 factors where the levels are given. Then we go to the flowchart. Flowchart starts with randomly assign. And we have 1, 2, 3, 4, 5, 6 groups. We have 2 energy drinks, 2 coffee, 1 energy drink, 2 coffee, 0 energy drink, 2 coffee, 2 energy drink, 0 coffee, 1 energy drink, 0 coffee, 0 energy drink, 0 coffee. 6 groups. And at the end, we compare results. Remember again, flowchart always starts with randomly assign, always ends with compare results. And we answer the questions. The factors are energy drink and coffee. We have 2 factors. For treatments, we have 6 treatments. 2 energy drinks, 2 coffee, 1 energy drink, 2 coffee, 0 energy drink, 2 coffee, 2 energy drink, 0 coffee, 1 energy drink, 0 coffee, 0 energy drink, 0 coffee. The response variable is how long they stay awake. Number of groups needed, 6. The control group is the 0 energy drink, 0 coffee group. Lurking variables, any allergies, the amount of coffee, how much caffeine is in the energy drink, how much caffeine is in the coffee, any of those things that affect the study. Number 9 says, give an example of an observational study. An observational study is where we watch people, observe people, or just collect data. So one example could be children at play. We just watch them play. Or maybe animals in the wild. We don't do anything. We just literally watch them and see how they interact. And then for an example of an experiment, we just completed 3 experiments. But remember, with an experiment, you have to have a treatment group and you have to have a control group. So for example, we randomly assign. One group gets aspirin for a headache and the other group gets a placebo. And at the end, we compare results. Okay. Question 11. Question 11 discusses discrete and continuous. Now remember, discrete are things we can count. Continuous are measurements. So the amount of soda in your cup is something we'd measure. That would be continuous. Even though you pour the same cup, how much is in there exactly, there's many answers, continuous amount of answers. How much time from when you leave your house to when you arrive at home, that is a measurement, that is continuous. How many people in the class? That's something we can count. That is discrete. You can count how many people in the class. Your blood pressure, that's something we measure, therefore it's continuous. And the number of donuts at your local donut shop, that's something we can count. That's discrete. So remember, if we're talking about measurement, time, how much soda, your blood pressure, those are all continuous. Things we can count, how many people in the class, how many donuts, those are discrete. Question 12. Your favorite color. So we have blue, 100 people, black, 90 people, green, 75 people, red, 60 people chose. If I want to find the probability and make a probability distribution graph, step 1, we add. We take 100 plus 90 plus 75 plus 60, which gives us a total of 325. So step 1 is we add. Then to find the probability of each one, we take 100 divided by 325. That gives us about 0.31. 90 divided by 325 gives us about 28. 75 divided by 325 gives us about 23. And the last one, if we have 60 divided by 325, we get about 0.18. It should add up to 1. Or if I'm talking about percents, 31%, 28%, 23%, 18%, which would add up to 100. And sometimes difficult to get it exactly at 1 or exactly at 100 and you get 101 or 99, and that's fine, as long as you're close. Then we're going to graph these. So I'm going to label we have blue, we have black, we have green, we have red. So we put the colors on the x-axis. Then we're going to put the probabilities on the y-axis. And our numbers, the lowest is 18 and the highest is 31. So maybe we'll start with 0. We'll go 0.10, 0.20, 0.30, up to 0.40. 10, 20, 30, 40. And blue was 31, so I draw a line up to 31, put a dot. Black was 28, I go up to about 28, put a dot. Green is 23, I go up to about 23, put a dot. And red is about 18, go up to about 18 and put a dot. That would be your probability graph. That would be your probability graph. Okay? Which leads us to our last set of questions. Our last set of questions discuss